Hello, Internet. No, my microphone didn't die this episode, but I wanted to tell you about the previous two episodes, which you have been forced to skip automatically. So the previous two episodes I thought were very boring, and I was writing up the description. I was like, sorry, these episodes are really boring. And I was like, well, wait, if I'm actually sorry, then I wouldn't subject people to them in the first place, right? Like, what kind of human would I be to apologize and then do it anyway? So don't worry, though. If you're like, no, Ben, I want to see you fiddle with the camera for like 30 to 40 minutes, because that's what the past two videos are. It's me being like, do I add, do I subtract, do I use square roots, blah, 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 blah. If you do want to see that, I have descriptions in the link below. I have links in the description below to those two videos. And so I didn't know what to do with the numbering. I guess I'm just going to renumber everything. I mean, this is like behind the scenes. You don't care, right? But I've already like pre-recorded all these and numbered them. And so now I'm going to like bump everything down to numbers, and I'll call these two like missing episodes, or whatever you want to call them. They're not that missing. You can find them. They'll be like, half part A and half part B, whatever. I don't know what episode number this is. This is how, despite having a system, I don't even know what I'm doing. So anyway, that's what happened. This episode starts with me showing the camera and the final thing of how it works, which is very convenient. So you can see that. And then in just like a minute, then I jump into working on the jumping mechanics, which was an accidental. I didn't mean for the jump thing, but it worked. Okay, so anyway, I'm going to shut up now and let's get to the real video. Hello, Internet. I am here again making the crazy pirate game that CoPilot, or rather GPT-2, has suggested I make, and has been then being made with the help of CoPilot. So I was having some camera math issues last time. I played a little bit of Donkey Kong Country because I was like, well, how does another game's camera work? What's a good game? I thought of Super Mario World, but I happened to find Donkey Kong Country the first. So yeah, this math is looking pretty good. I can kind of explain the reasoning. So this little check is just, anything you have something interpolating toward a value where the values are getting smaller, and I'll show you how it plays. I should start with wonderful visuals rather than texting. But you just, so I have this thing where it goes fast at first and then it slows down into the view, and it definitely feels a lot better now. I mean, this is great. And you run forward, you move forward ever so slightly on the thing. I don't know if that's an accident of, so I noticed that was happening in Donkey Kong Country, and that was happening a little bit to my camera, but it was a little more than I felt theirs was. So I was like, I don't know if it was an accident, that's how it happened in Donkey Kong Country 1, or if it was totally intentional. I'm going to assume the best of their designers and think that they were like, yeah, it's good to have a little bit of forward motion, So that's what's happening here. Tried to mimic their thing. And of course, that's a 4x3 game, right? Whereas, old school TV size. So, I had to make some adjustments. But yeah, their camera basically does work like this, though. As soon as you tap the other direction, the camera starts panning over. Theirs actually goes too slowly. So, and even playing in the first level, I had a moment where I turned around and there was an enemy there and I couldn't see him because the camera, it's much more lazy about getting started to go where you're facing. And maybe that's good. Maybe you don't want, situations like this. I don't know. So maybe I'll revisit it, but I think we want to quickly see what's in the direction we're moving. I mean, we also have more space than Donkey Kong Country did, so maybe it's, the exact same logic there would work better here just by having more space. But anyway, because there is this, it goes fast at first and then eases into view, based on the difference here, the amount it's moving is smaller and smaller and smaller. And at some point, I just want to say, stop doing silly math and just get to where you want to go. Because you can get in these places, in fact, it's almost guaranteed that it's just going to keep jiggling around the target point because just because of how rounding of floats work, you're not actually ever going to hit the value. Also, making strict comparisons is difficult. And I think in this case, that actually would not have happened because we would eventually pass this less than threshold. So maybe it actually isn't an issue. Maybe I don't need this. Anyway, that's why I put it in. But now that I'm talking through it, we're never checking for equality. We're checking for less than. So I think we don't actually need it. So you know what? I'm going to delete it. Why do extra math we don't need? And we're going to be moving so much that it probably doesn't help anyway. Okay, so never mind that part. So this square root I threw in here, what I wanted was, I essentially wanted to make smaller numbers count more, so that even when you're very close, you're still moving a bit, because it felt like it was slowing down. Like the difference between the top speed and the minimum speed once it was getting in, it was drawn out too long. So by doing a square root, that accomplishes that, right? We kind of flattened that curve. So anyway, that just felt a little better than doing a straight subtraction and multiply. It felt a little better to me to have a square root. So that's what I did. Whether or not they're doing that in Donkey Kong Country, I've got no clue. But that's what I'm doing. So I feel like the camera is good. Now, oh my goodness, we need to jump, which is going to introduce a whole bunch more camera issues. But we need to jump. And I think this is where I want to think about the fact that the physics of the entities will be different. So for a player, so we've got creature. Yeah, I think we want a creature to know its jump strength, let's say. And maybe creatures should have their own gravity rather than having a gravitational constant, like I was talking about before. Maybe every creature follows its own gravity, and that could allow for things that, you know, fall more slowly, have different jump arcs. Again, mimicking the real world, mimicking real world physics in a 2D platform. This is known, it's a bad idea because real world physics don't make for nice controls. It was really, I love watching those videos where they like calculate, you know, how fast does Sonic go in real life? And you're doing pixel measurements. You're like, oh my God, the force of gravity in Sonic 1 is like 20 times that of Earth. That's the only way you could explain this jump curve. He'd be crushed by his own weight. You know, there's all these funny things. I don't know, 20 times, I don't know that that's enough to crush you under your own weight. But anyway, so yes, video game physics do not do real physics. So I don't feel bad about every creature having their own gravity. So that sounds good. Other possible things would be things like friction. Right now you stop instantly. I know I'm not going to want that because having slippery ice ground is... How many games? Yeah, games still do that. I was like, do games still do that? Yeah, they definitely do. I don't know, I think of like Mario 3 having that ice world, and that was all over the place. But I think even like Super Mario Galaxy and stuff, there were ice. Well, there was like the ice skating thing as a special mechanic. I don't know. I mean, it is taking away control is what ice does. So I can see where maybe games have decided that less ice is a good thing. I don't know. I feel like ice doesn't come up as much in games as it used to. But that could just be, you know, some selective bias, familiarity, you know, who knows. So anyway, at some point I think I'll want friction is what I'm saying. I'll go ham on the ice. I don't know that I will. We won't do that much ice. But anyway, yes, thinking not about the words I just said and instead about programming, let's program some of this. And I'm hoping that the AI, CoPilot, can help with this more. I feel like I haven't been using CoPilot a whole lot. So let's do that. We're going to have to take into account things like, you know, the width and height and collision with terrain and all that stuff, which currently is not happening, right? If I had a wall, I would pass right through it. So we need to fix all that stuff. And in fact, let's first set up the world so that there is such an obstacle so that we can test that stuff. So where is, I think it's the world state where I currently like initialize a fake world. Nope, it's loaded tiles, right? Because at some point this will actually procedurally generate the world. So let's do, I'll just put an if statement here. We'll do like if the x equals 220, because that should be pretty quickly in view. Let's do 210 instead, because you start at 200, right? So 10 tiles to the right. Let's do things a little bit differently. Here we would do this, but we're going to do, again, we're going to do it differently. So we'll do 2, -1, and then we will do a one of these, a background dirt block. So this should have the effect I want. Let's check it out and demonstrate that we can walk straight through the ground and it doesn't even matter. I mean, the tiles right now are pure decoration. That's kind of the effect I want. Ooh, did that seem? Hopefully that was just some weird startup. Anyway, womp, we go straight through. It's like they don't even exist. Wow, maybe that camera, maybe that is kind of a dizzying speed that turns at. I gotta listen to the masters. I should just do whatever Donkey Kong Country does. Okay, let's close this. I'm worried about the camera for like way too many videos in a row. We'll revisit that later. Let's make some physics happen. So I was thinking just now, maybe I could start with the X physics and then add the Y, but there's no reason to. We can just do both and at once. And actually, just to kind of prove to ourselves that anything is working, let's start the player like a little off the ground. 65, sure, 15 pixels off the ground. So they should start falling once we have any kind of gravity working. So next thing would be to update them. So currently I think running around, oh yeah, we call update on the creature or the player controller. See, again, I just don't think this is the right place for this logic. I think, what do I think? Let's not think about it too hard. Let's assume all creatures are going to behave the same. I'll move the logic where I think it closer to where I think it should be, because this is wrong. And then when I need creatures to start behaving differently, then I will put the logic in. So what I'm thinking is that in the world state, we would ask it to update all of its creatures. So let's give it an update. And I want you to loop through all your creatures and apply all your physics and do all their, yeah. And again, things might have their own unique physics, and we'll figure that out later. But right now, they're all going to have the same physics. So it's a little suboptimal, but let's have a list of creatures. That'll do. Add the player rather, sorry. So we know what we're drawing, but drawing is different. So for each creature in creatures, yeah, creature update, that'll work for me. Not really, actually. I want to say like update creature. Help me out, AI. You gonna write update creature for me? No? I think it was just then starting to. I really wish I had the same indicator. I've mentioned this in a previous video, like a different, not part of the Pirates series. Are we calling, is that what we're calling this? But anyway. All right, so lowercase creature now. You have a movement speed. Here's the world's time constant. So this would move you left and right, except we don't necessarily want to move you left and right. So what we want to do is want to test out this new x. So let's do a float new x equals x. Well, it would be that plus all this. Plus all this. I don't know why I indented so far. No, don't indent that far. I don't like that. I mean, I see what you're doing, and I don't like you doing it. I know there's an option for that somewhere in the settings. And we're going to want a new y. Can you figure out new y? Kind of. We want it to be based on the gravity of the creature. Oh, it's going to do it again, isn't it? Oh, yeah, thanks, AI. Okay, so now we want to see... Actually, let's check the x's first. Oh. Okay, if new x, or let's get the tile. We need to know a few things. So if the creature x velocity is greater than 0, whoops. Oh my god, whatever, I'll deal with that later. AI, help me out here. I'm trying to do something. If it's greater than 0, then we need to check things to the left, on its right edge, right? So let's do tile equals, do you know the world, right? Ooh, you don't have that service? World state. It would be the loaded tiles. Yeah, okay, you're gonna need access to loaded tiles. Loaded tiles, whoops. And perfect. So loaded tiles, get tile. So let's say, tile X. Yep. Now it's filling in. See, that's interesting. So was it looking ahead or not? I don't understand how they're doing this. Okay. So that's not exactly, but we want like your right edge. So that would be the new X plus the creature's width -1. Because, right, if you're at pixel 0 and you're 3 pixels wide, then your pixel 3 is not your right edge. It's 0, 1, 2, so we need to subtract 1. Hopefully that made sense. So we want to check your right edge, and we don't know how tall you are. So different things can be different heights, and we're gonna then need to check every 50 pixels, because that's the height of a tile, or rather we need to check the height. So what we can't do is just check the corners, because if the character being moved is taller than a tile, if we only check the top and bottom corner, then it's possible your top and bottom corner are on opposite sides of the tile, and then you would slide through if you were positioned just right. So we need to check the top and bottom and every in between no more than 50 pixels, if that's making sense. So how do we express that? We're going to want, it's going to be a list of integers. Yeah, that's accurate. Do you know what I want to do? Ooh, add floor of the creature y plus I. Yeah, but that's too many. We want to, so we definitely want to hit the top, and we definitely want to hit the bottom. I feel like we should be able to figure out. I guess we don't need to. We just plus equal tile height, or yeah, tile height. But my cat is making a noise. So yeah, I guess that's true. That would be a Y to check. I'm gonna miss, right now I'm gonna miss the bottom if I do this. I think what I wanna do is add the tile height and subtract 1 again. So let's think about this. Suppose you are 20 pixels tall. Then this is bad and you're gonna go too far, is what's gonna happen. Because then we would say go to 20 plus 49, 69, internet's favorite number, one of the two. And what, yeah, we don't want to go that far. We don't want to pass the bottom. I should only go to height. I want to make sure to hit the height. Maybe what I do instead is I manually add the bottom and I start from, or sorry, manually add the top. I always have to hit the bottom. Maybe this is fine, we just add the bottom afterwards. So maybe what I do is say -1. So we miss the bottom, but then we add it in manually, like this. So this would be plus creature thing height -1. Those are all the tile Ys, and we can actually add a distinct afterwards. Like, we don't need to include all of them, but because we might get a duplicate. But would we? No, I think we won't. Oh yeah, we could for tiles. But again, we won't, because we're incrementing by height. So yeah, we don't need to do that. We don't need to throw in a distinct. And then we need to get all the tiles at all these Y positions. This is exciting. So get tiles, let's say, and I'll make a new thing that does this, that allows for this. We'll get all the tiles that are on your right edge. And we need to check if any of those were solid. But get tiles is not defined. 18 minutes. No, let's just do this. Let's just do this. I'll write get tiles because that should be easy enough. So we're going to do get tiles. Oh, what? Oh. Get tile, yeah. And we'll have a couple versions of these, right? So you will return an IEnumerable. And I want IEnumerable because I could imagine using these functions later. In fact, I will be right now. I'll just want to find the very first one that fits this description. And then we can stop, right? The moment we hit something that collides, we don't have to look any further for this particular purpose. So get tiles int x, and then this would be a, I guess it also would be an IEnumerable of tile y, or tile x and tile y's. And then AI, will you suggest something and will you use yield? Yes, you will. Okay, that is what I want because, again, I'm going to use link to say, you know, do any of them collide? And then I won't have to go through the whole array, you know, the first time. It won't actually get tiles for all these, so it'll be a little more efficient. And I can probably compute the tile-wise in a similar way. Where's the running around? Nope, where's the world state? Was this it? I mean, really, this is an excuse for just checking here. I don't know. Yeah, interesting. That would probably be a little more efficient rather than the overhead of all this. But 20 minutes, I'm going to stop now and pick this up in the next video. And hopefully we'll have some collision in just a video or two. Thank you.